Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandar. Students, in this Transformers through topic wise MCQ series, we have completed up to 10 sessions. It is the 11th one. Okay, in this we are going to discuss the MCQs belongs to auto transformer. Okay, so you know very well auto transformer questions are very important. Let us start the session. Okay. The primary and secondary windings of an autotransformer are dash. Magnetically coupled, electrically coupled, both magnetically and electrically coupled, none of this. Here in autotransformer, we have only one winding is there. So we have both magnetically and electrically coupled. Okay. So if you can consider two winding transformer, that two winding transformer, both windings are separated, that means electrically separated, magnetically coupled. Okay, so here the power transfer takes place through magnetical only, magnetical coupled, coupled, electrically isolated, isolated. Okay, so coming to auto transformer, only one winding is there. Okay, so if you have the magnetic core, only one winding is there. Okay, so these turns are primary turns. Why? Because if it is connected to the supply, then it is considered as primary turns. And secondary connected anywhere here, that is connected to the load, that is secondary. So these turns from this one to this turns N2. Okay, and this part is nothing but N1 minus N2. So this is considered as V1 volt. This is considered as voltage across the load is V2. Okay, then this voltage across this winding is V1 minus V2. So this is the current I1, load current is I2. Okay, so this current is nothing but current in common winding. This is the common winding, guys. Okay, from this point to this point is the common winding. So it is common for both primary and secondary. Okay, so here direct contact between the primary and secondary na. So here we can say electrically coupling, and also through the flux also here magnetic core is there, so magnetically also coupled, both electrical and magnetical. In auto transformer, power is transferred through dash. Just now we have discussed it is electrically and magnetically coupled. Electrical means conduction, magnetic means induction. So here power is transferred both conduction and also induction process. Okay. Secondary winding of an auto transformer is also called as dash. Just now I have given. This is the secondary winding na, from this one to this one is considered as secondary winding. So this is also considered as common winding. It is common for both and secondary, for primary and secondary. So common winding. So the answer is option B. Okay. Coming to the next question, it is advisable to use the auto transformer if transformation ratio is dash. Whenever the transformation ratio is greater than or equal to 0.33, then only the auto transformer is feasible. What does it mean? Transformation ratio for this auto transformer K is equal to low voltage by high voltage. It is always less than 1. Na? LV by HV means always less than 1. Low voltage in the numerator means less. High denominator more means always less than 1 you will get. Okay. Whenever this K value is greater than or equal to 0.33, then only auto transformer feasible. That means we cannot step up or step down the voltages more than this one. For example, if you can consider 33 kV to 11 kilovolt or 11 kV to 33 kilovolt, whatever it may be. In this case, what is the K, guys? LV by HV. 1 by, so 11 by 33, 1 by 3. That means 0.33. So 0.33 means like greater than or equal to na. So it is equal also means prefer. Auto transformer is feasible. Okay. And if you can consider in the same way, 11 kilovolt to 66.6 kilovolt. Okay, 11 kilovolt and 6.6 kilovolt. Then K is equal to 6.6 by 11. So that means almost more than 0.33. So it is greater than 0.33. So here also it is preferred to make auto transformer. That means we can convert 11 kilovolt to 33 kilovolt or 33 kilovolt to 11 kilovolt. That is possible. 11 to 6.6, 6.6 to 11 also possible. For example, if we have 132 kilovolts to 11 kilovolts, then K is equal to 11 by 132. It is less than 0.33 na. So it is not feasible. Not feasible in the sense we cannot make the auto transformer from 132 to this much of less voltage, or from this much of less voltage to this 132 of high voltage. Okay, so that much of changes we cannot get by using this auto transformer. Okay, all of you getting? We can convert the voltages, or we can reduce the voltages up to certain limit. We cannot reduce a lot, or we can increase the voltage up to a certain limit, but we may not increase very higher like a two winding transformer. Okay, so if you want to design the auto transformer, K has to be greater than or equal to 0.33. Coming to the next question, guys. A two winding transformer is converted into auto transformer if we apply additive polarity and subtractive polarity for the connections. Then the secondary voltage is 2640, 2160 volts respectively. What is the ratio of primary and secondary voltage of the original transformer? Okay. Here they have given additive polarity case, the voltages are 2640 na. Let us take for additive polarity, that is E1 plus E2 is equal to 2640. In case of subtractive polarity, that is E1 minus E2 is equal to 2160. From this one, we can easily find out the E1 and E2 values now. Okay, these two are cancelled out. 2E1 is equal to 0, 6, 4, 10, 8, 4800. So E1 is equal to 2400. If the E1 is equal to 2400, what about the E2? 240 na? Okay, E2 is 240. So what is the ratio of their primary and secondary? 2400 by 240, that is 10 is to 1. Okay, that is 10 is to 1. So the answer is option B. The answer is option B. Okay, coming to the next question, guys. A two winding 220 volts to 110 volts 1.5 kVA transformer is reconnected as 220 bar 330 volt auto transformer. Then it is re-rated as. We know very well the kVA rating. Coming to kVA rating of auto transformer. kVA rating is increases. So just remember that one. Increases means 1 by 1 minus K times of the two winding transformer. Okay, 1 by 1 minus K is the transformer LV by HV now. So here it as like this 220 by LV by HV. Okay, 2 by 3. So 2 by 3 into 2 winding transformer has 1.5. So that is 3 minus 2 1 and 3 comes to numerator. 3 into 1.5, that is 4.5. So it will becomes 4.5 kVA. Will becomes 4.5 kVA. Okay, all of you clear? So I want to give some data about this auto transformer. So all of you try to note it down. Okay, so here in auto transformer, in case of auto transformer, the kVA through the conduction, they're asking the question kVA by the conduction method, that is K into input kVA. K into input kVA. If through the conduction is K, then what about the induction? 1 minus K. Okay. Wait. kVA transfer through induction is remaining 1 minus K times of the input kVA. So very important, guys, all of you note it down. Okay. And coming to the weight of copper, if you use the two winding into auto transformer, weight of copper also reduces. Okay. In auto transformer, that is 1 minus K times of the two winding transfer. Okay, 1 minus K times. That means here weight of the copper is reduces. And coming to the next one, percentage full load losses. Losses are also reduces now. These are also 1 minus K times of the two winding transfer. Okay, and percentage voltage drop. Voltage drop also reduces. So that means this is also 1 minus K times of the two winding transformer voltage drop. Okay, the final one, kVA rating. We know kVA rating will be increases. Increases means is 1 by 1 minus K times two winding transfer. So this is the formula we have used now. Okay, coming to the next question. What is the power transmitted inductively in transformer which supplies a load at 161 volt when applied a primary voltage of 230 volts? Okay. Power transfer through the inductively. Through the inductively, what is the formula I have given? 1 minus K times of the two winding transformer. Na? 1 minus K times. So in this case, we want to find out the K. K is nothing but LV by HV. LV is 161 by 230. That is approximately 0.7. Okay. 0.7. So power transferred inductively is nothing but 1 minus K times of total power or two winding total power. Okay, here also you can make it as total power. Total power. Input kVA means total power. Now 1 minus K is 0.7 times of the total power transmitted. So or that is nothing but input power. So that is 0.3. That is nothing but 30% of input. So the answer is option D na. So the answer is option D. If you know the formula, then you can easily get. If it is 30% remaining, it is nothing but conduction. So conductively 70%. 70%. Okay. Coming to the next question. What is the power transferred conductively from primary to secondary of an autotransformer having transformation ratio is 0.8, supplying a load of 3 kilowatt? So here they are asking conductively. Conductively. That is K into input power or total power. K is 0.8. Input power they have given 3 kilowatt. That is 2.4 kilowatt. Remaining inductively. 0.6 kilowatt. Okay. So conductively they are asking 2.4. Coming to the next question, guys. A 2000 volt bar, 200 volt, 20 kVA, the winding single phase transformer is reconnected as a step up auto transformer having 200 volt bar, 220 volt ratings. Then the power rating for the auto transformer will be dash. Here we can find out this one. Here K is equal to LV by HV. 1 by 11 you are getting. 1 by 11. So power rating of the auto transformer or kVA rating is nothing but 1 by 1 minus K into 2 winding transformer na is 1 by 1 minus 1 by 11 into 20 kVA, that is equal to 11 minus 1 10, 11 by 10 into 20. So that is nothing but 22 kVA. So the answer is option D. Okay, so you can also get the answer by using the diagram also, but diagram will take more time. So try to go with this method. Coming to the next one, the ratio of primary by secondary voltage is 2:1. The saving in terms of weight of the copper required in an auto transformer is used instead of two winding transformer. I have already given the weight of the copper. Weight of copper requirement in auto transformer. What is the formula? Weight required is less. Less means 1 minus K times of the two winding transformer. 1 minus, here K is LV by HV. Those ratios are nothing but 1 by 2, not 2:1. Less low voltage 1, high voltage is 2 ratio, 1 by 2. 1 minus 1 by 2 of the two winding transformer. So that is 1 by 2 of the two winding. That is 1 by 2 means 50%. 50% copper you can say. Okay, 50% copper you can say. Coming to the next question, guys. In an auto transformer, the number of turns in the primary winding is 210 and in secondary winding is 140. If the input current is 60 amps, the current in output and common winding are dash. So let us take the auto transformer. It has only one winding. Okay. So the secondary is connected between that. Load. Across the load is V2 and this is the I2. This is the primary current or I1. So this is the voltage V1. Okay, so they have given the input current. This is 60 amps they have given. Okay, so here the primary turns are 210 turns, secondary turns are, these are secondary turns are 140. Okay, so that means here voltage is going to be high turns to low turns means voltage is going to be reduces. That means current will be increases. Okay, current will be increases. So here primary current is 60 amps means secondary current is simply greater than 60 amps. All of you getting my point? Transformer actually is nothing but whenever the voltage increases, current has to be increases. So 60 amps is the input means output must be greater than the 60 amps. Greater than the 60 amps, we have the two options. We have the two options are there. Sorry, greater than the 60 amps. Yes. Okay. Output current is greater than 60 amps. We have the two options are there. Output greater than 60, 675 and 90. Okay. So two options are there means we have to calculate only. Okay, so let us take the ratio V1 by V2 is equal to I2 by I1 is equal to that is N1 by N2. Okay, 1 by N2. So if from this one, if we want I2, I2 is equal to I1 into N1 by N2. So I1 is nothing but primary 60, N1 by N2, 210 by N2 is nothing but 140. Okay, so 72 73, so once 230, that is 90 amps. Okay, all of you getting this is the 90 amps. If this is the 90 amps, 60 amps is coming from this, 90 amps is the output, remaining amps will be 90 minus 60, 30 amps will be coming from this. Okay, very easy. Total is a 90, 60 coming from this means remaining 30 will be comes from this. Now they are asking the currents in output. Output is 90 amps. This is the common winding now. In common winding, how much? 30 amps. So answer is option B. Clear. A very easy question. Okay. From the number of turns, we can calculate the currents. As the voltages are decreases means current increases. Current increases in terms of the same ratio. Same ratio. So 90 amps it will be reached to 90 amps. So 60 amps coming from this means remaining 30 amps comes from common winding. Okay. Coming to the next question. A 10 kVA auto transformer, the transformation ratio is 0.4. Find the power transferred inductively. Inductively is nothing but 1 minus K times of the input kVA, correct? Or input power 1 minus K, 1 minus transformation ratio they have given 0.4, input is 10 kVA, 0.6 into 10 that is 6 kVA. So answer is option C, 6 kVA. Coming to the next question guys, in an auto transformer of voltage ratio the fraction of power transferred inductively is proportional to dash. Voltage ratio, the fraction of power transferred inductively is proportional to dash. So what is the power transfer through the inductively? 1 minus, right, 1 minus P times of 1 minus K times the input. Okay, so 1 minus K. K is nothing but LV by HV. So here K is considered as V2 by V1, then V1 minus V2 by V1 minus V2 by V1. So the answer is option D. Okay, the answer is option D. V1 minus V2 by V1. Okay, based upon 1 minus kV of the input. K is LV by HV. Generally, we are considering step down auto transformer. Primary winding is higher means voltage V1 also higher. So this is the V2 if you can consider. Less number of low voltage, it is the high voltage. So K is equal to consider as LV by HV, that is V2 by, okay, and we got the answer. Coming to the next question, guys. Neglecting the losses if the power transformed inductively is equal to power transformed conductively in an auto transformer, then secondary to primary ratio of the transformer is dash. Secondary to primary ratio of the transformer is dash. Okay. Inductively is 1 minus K times equal to conductively K times. So K comes to this side, 2K is equal to 1, K is equal to 1 by 2, that is equal to 0.5. That is nothing but secondary to primary ratio. Na? K is nothing but LV by HV. LV is generally secondary side, HV is generally primary side. So that ratio is 0.5. So 0.5 means answer is option A. Okay, 0.5 means answer is option. Okay, students, so we have completed almost all the questions in the transformers. I think we have covered so many topics in the transformer as per JE examination. So these sessions are very much useful for your all the state JE and A examinations like SSC JE, RRB JE, or your state JE or A examination. If you like my classes, please click on like button and also share the information to all your friends and try to join in the telegram link. I have provided the PDF of all these with the solutions. Okay, so I will provide the link in the description box. You can join in that. And one more thing, students, if you want to buy any product from online, that is like Amazon and Flipkart, you can buy from through my links. I will provide the links in the description box and also in the comment box. Okay, so that may be a little bit help for me to develop this channel. Okay. Okay, students, thank you for your support for continuous watching of all these sessions. Okay, but my main intention is you have to get into the job. That is the main intention. You are watching or not watching is not important for me. So you are getting the job or not. I will try my level best to get uh, you. That means you have to be get the job. Okay. Okay, students, thank you so much, guys.